Okay, we're going to take a look at something called transformations. Transformation is a geometry term. So on your notes, find the section that says transformations. And I want you to write, we're just going to write a general statement about transformations. In geometry, a transformation refers to the movement of objects in the coordinate plane. Now, if you think about this, a transformation in normal life, in your everyday life, if you think about like online, you'll see all the time pictures of people's like Transformation Tuesday or whatever, where they show a picture of their transformation, whether it's from they were heavy and they lost weight, or maybe they were awkward middle school and now they're adults and they are beautiful or whatever. There are these transformations that you see all the time. And that's when a person changes. Well, in geometry or in math, a transformation is when the shape changes. What we're going to be looking at in this unit is movement. So our line or our shape or line or point might move. It might rotate. It might flip. Okay, so we're looking at different ways that the shapes are going to change. So pause and get this copied. Okay, next one. Oops, let's clear that. Okay, so what I want you to look at is the next box says translations. And we're going to talk about a few things with this specific transformation called a translation. So this first box says action, and what this is going to mean is what does a translation look like? Okay, so the point, line, or shape slides. So with a translation, we're looking at a slide, a movement. It'll move up and down or left and right. So it's going to move up or down, left or right. Okay. All right, the next thing is let's put this in words. These are the instructions that you might see in words. So you might see it say translate a certain number. Oops. Right or left, or a certain number up or down. So what's going to happen is you're going to be given a number. Move 2 to the right and 4 down, or 1 to the left, 3 down, 1 to the left, 3 up. Okay, that's an example of what the directions will look like. You may also get your instructions written using algebra. And here's what that looks like. You'll be given an ordered pair and then you'll have an arrow. And the arrow tells you this is what's going to happen to each of these coordinates. the x is either going to be added or subtracted. So it'll be x plus or minus some number. Then you'll have your y coordinate plus or minus some number. So it might say x plus 2, y minus 1. What that means is if it's x plus some number, you're going to move to the right. And we're going to see this happen in just a minute. If it's x minus a number, you're going to move to the left. If we think about it, if you add a number, if you think about your x coordinates and your x-axis, if the x gets larger on a number line, you move to the right. If an x gets smaller, you move to the left. With our y's, if the y gets larger, we move up. If a y gets smaller, we move down. It says down. Okay, and we're going to see this in action in just a minute. So hit pause and get this copied. Okay, let's take a look at an example. All right. We're going to translate the shape, and our instructions in words says, so our words say 2 to the right, 4 down. Here's what that means. Okay, that means each of these points here, okay, what we do is we go to, oops, let me get a different color. What that means is each of our corners of our shape so each corner point or vertice, okay, so each corner point moves. So what's going to happen is if I say 2 right and 4 down, D is going to move 2 to the right and then 4 down. Okay, so 2 to the right and 4 down. Okay, let's take a look and see what that looks like. So each of our corner points are going to move 2 to the right and 4 down. So what you're going to see is if I take this blue triangle, I'm going to move it 1 to the right, 2 to the right, 1 down, 2 down, 3 down, 4 down. Okay, so if we compare our two shapes here, I have my first shape in red, DEF, and then my translated shape is the blue down below. Couple things to note when we notate these and when we label our vertices or our corners. It keeps the same letter except you're going to see a little apostrophe. That's just that says it's the image. What happens is our new shape is called the image, and our old shape is called the pre-image. Okay, so the old shape is the pre-image, and our new shape is the image. Okay, so what we want to see is D becomes the image of D. F becomes the image of F. E becomes the image of E. Let's take a look at our ordered pairs for a second. So our pre-image is triangle DEF. So write that underneath the word pre-image by this table. And we're going to write the ordered pairs for each of our corners or our vertices. I'm going to label it DEF. So my ordered pair for D, if we start at the origin and get our ordered pair, D is at -3, 4. E is at -3, 1. And F is at 1, 1. Now let's take a look at the ordered pairs of our image. Our image is triangle, image D, image E, image F. So copy that down. Then we're going to take a look at our ordered pairs for image D, image E, and image F. So if I just use the picture, okay, so I'm going to use the picture to come up with our ordered pairs. D is at 0, excuse me, not 0. D is at -1, 0. Image E is at -1, -3. And image F is at 3, -3. Now, something I want you to notice, I want you to take note of this piece right here, this algebra. Okay. What this algebra portion is saying is it's telling us the x coordinate, which is our pre-image coordinate, I'm going to add 2 to that x coordinate. Adding 2 is going to move my shape to the right. Okay, so think about it again. If I look at E, the ordered pair of E was -3, 1. And I'm going to move this 2 to the right. My ordered pair now becomes -1, and then I'm going to end up going down. So if I took x was -3, and I add 2, I get -1. And that's what we have right here, -1. So you could actually have gotten this table using math and not drawing a thing. Okay, so you can avoid drawing anything if you do the math. All right, or you can draw it. It's up to you, whatever. So -3 plus 2 is -1. Then I have y minus 4. 4 minus 4 is 0. And if you look at these two tables, you'll notice that every single time, the red pre-image, if I add 2 to the x value, I get the new x value. If I subtract 4 from the y value, I get the new y value. So keep that in mind. Okay, and let's look at our next slide. On the next one, we are going to translate, and we have a little project here to do. So, so number 1 says pre-image rectangle ABCD has vertices A, B, C, and D. Just giving us information. We can go ahead and draw it right now if we want. So A is -3, -2. B is -3, 1. C is 2, 1. And D is 2, -2. And then I get mine. Hopefully your rectangle is much better than mine. So there's our rectangle. This is horrendous. Oh goodness. Okay. Definitely do not make yours look like mine. Okay, number 2, describe the translation. So we want to look at this algebra and put it into words. Basically, here's what's happening. X minus 1. Imagine any x coordinate. If I take away 1 or subtract 1, I'm going to move, where's my mouse? I'm going to be moving to the left 1. So if I subtract 1, I'm going to be moving this way 1 from whatever point I'm at. So that's to the left. Y plus 3. Now the y is my up and down value. And I'm going to add 3, which means whatever y value I have is going to increase by 3 or move up 3. Okay. So if I take a look at my new coordinates, without drawing anything, let's use this left 1 and up 3. So my x, I'm going to end up with -3 minus 1. Add the opposite, and my new a value should be -4. And I'm going to change the color just so we can see everything. And then my y value is y plus 3. So I'm going to take this -2, and I'm going to add 3. -2 plus 3 is 1. Now if I do it physically with a right here, I'm going to go to the left 1 and up 3. There's my new A. If I look at my ordered pair, it is negative 4, 1. Perfect. So for B, negative 3 minus 2, negative 3 minus 1 is negative 4. Y plus 3, my Y was a 1. 1 plus 3 is 4. Let's test it out. If I have B, I'm going to move to the left 1 and up 1, 2, 3. And there's my new B. And it is 4, negative 4. So I can go to my point here. I'm going to go left 1 and up 1, 2, 3 and get my image of C. D, I'm going to move left 1 and up 1, 2, 3, my image of D. There's my new rectangle. And if I look at my ordered pairs for C, it should be 1, 4, and my new D is 1, 1. Make this a little more clear. Look like a letter, not a 4. And if we look at the algebra of it, if I look at C, if I say 2 minus 1 and 1 plus 3, 2 minus 1 is 1, 1 plus 3 is 4. D, 2 minus 2, negative 2 plus 3. 2 minus 2 is 1, negative 2 plus 3 is 1. So all my ordered pairs match up, the math works, and then we drew and labeled A, B, C, D in the process. And that's it.